Imagine a place so dark, so cold, and so crushing that most machines collapse under its weight. Now imagine that instead of looking to the stars, NASA is diving headfirst into this alien world right here on Earth. It might sound like science fiction, but it's not. It's the deep ocean, our planet's final frontier, and NASA is treating it with the same intensity it once reserved for the Moon and Mars. In a world where survival seems impossible, life is not just surviving, it's thriving. What NASA is finding beneath the waves might be the key to finding life beyond Earth. NASA has always been a name tied to the stars. From that historic moment when humans first stepped onto the Moon to the rovers currently crawling across the dusty surface of Mars, the agency has been at the forefront of space exploration. But in recent years, something unexpected has happened. Instead of only looking up, NASA is now looking down, into the darkest depths of our oceans. It might sound strange at first. Why would a space agency care about the ocean? But when you think about it, it makes perfect sense. The deep ocean mimics space in eerie and fascinating ways. In the deepest parts of the ocean, sunlight never reaches. Temperatures plunge to freezing. The pressure is so immense that it can crush metal. These environments are so extreme, they were once thought to be completely lifeless. But when scientists explored them, they were shocked. Not only was there life, but it was absolutely bizarre. Glowing creatures, fish with transparent bodies, and worms that live off chemicals instead of sunlight. And that's exactly why NASA is diving in. If life can survive here, maybe, just maybe, it can survive on distant alien worlds like Saturn's icy moon Titan. NASA's fascination with the ocean actually isn't new. It dates all the way back to the 1960s when the space race was in full swing. While the world's eyes were on the moon, a few pioneers realized the ocean had lessons of its own. The challenges of surviving in space, extreme pressure, isolation, limited resources, are almost identical to those found in the deep sea. If humans could live underwater for long periods, they might be able to survive deep space missions too. This idea led to one of the most fascinating projects of the time, a program called CABAB. CABAB wasn't a NASA project. It was led by the US Navy. But its goals were deeply connected to space exploration. In 1965, the CAB-2 mission sent a team of aquanauts to live in an underwater habitat over 200 feet below the ocean's surface. They stayed there for weeks, running experiments, testing technology, and proving that humans could survive and work in extreme, pressurized environments. It was a groundbreaking success. But like space exploration, this came with serious risks. In 1969, a tragic accident during the CAB-3 mission claimed the life of an aquanaut, bringing the project to a heartbreaking end. Despite that loss, the lessons from CABAB echoed through future missions. NASA took those insights and built upon them. Today, NASA uses the ocean not just for inspiration but as an actual training ground. Off the coast of Florida, there's an underwater lab called the Aquarius Reef Base. It sits 62 feet beneath the surface and is home to NASA's NEMO missions, short for NASA Extreme Environment Mission Operations. Here, astronauts train for spacewalks, equipment failures, and other emergencies, while surrounded by fish instead of stars. The ocean becomes their rehearsal stage for the International Space Station and future Mars missions. Life inside Aquarius isn't glamorous. The habitat is small and cramped, packed with equipment. Every action has to be carefully coordinated. Eating, sleeping, even using the bathroom, everything is done in close quarters with full reliance on life support systems. The experience mirrors space missions so closely that many astronauts say their time underwater was the best preparation they ever had. But NASA isn't just interested in training anymore. The agency now wants to explore the deepest parts of the ocean, places few have dared to go, hoping to uncover signs of life that mirror what we might find beyond Earth. But reaching these depths is no easy task. The ocean's deepest zones, known as the Hadal zones, are some of the most hostile environments on the planet. Salt water corrodes. The pressure crushes. The cold seeps into everything. Over the years, NASA and its partners have designed advanced probes to explore these depths, but not all missions have succeeded. Some vehicles were destroyed by pressure. Others simply vanished. Still, the push continues. Because what lies down there could be the key to understanding how life begins, and whether we're truly alone in the universe. One of the most famous deep-sea regions is the Mariana Trench in the western Pacific Ocean. It stretches over 1,500 miles long and 43 miles wide. That's 120 times larger than the Grand Canyon. But its size isn't what makes it so fascinating, it's the depth. At its lowest point, Challenger Deep, the ocean floor is nearly 7 miles beneath the surface. That's deeper than Mount Everest is tall. The pressure down there reaches a staggering 15,000 pounds per square inch, enough to crush most submarines like an empty soda can. Only a handful of people have ever reached this abyss. In 1960, two brave men, Don Walsh and Jacques Picard, made history. They climbed into a strange, deep-diving vessel called the Trieste. It wasn't a sleek submarine, it was more like a metal egg attached to a gas-filled float. But it was built for one purpose: to survive the crushing depths of the ocean. For nearly 5 hours they descended in darkness, the temperature dropping, the pressure rising. Then they reached the bottom of Challenger Deep. What they found shocked them. Despite the hostile conditions, life was there, a flatfish swimming along the seafloor. It was a moment that changed everything we thought we knew. For decades, no one else made it to the bottom. Then in 2012, filmmaker James Cameron, the man behind Titanic and Avatar, took on the challenge. He piloted a high-tech sub called the Deep-Sea Challenger, designed for a solo dive. Unlike the bulky Trieste, this sleek vertical vehicle was packed with cameras and scientific tools. On March 26, Cameron descended to the bottom of Challenger Deep, reaching a depth of 35,787 feet. He became the first person ever to make the journey alone, and only the third human in history to touch the seafloor at those depths. Cameron's journey wasn't just about making headlines. He brought back stunning footage and scientific data. He discovered bizarre, previously unknown creatures, including the squid worm, a nightmarish organism that looks like it belongs in a sci-fi movie. His mission proved once again that the deep ocean, like space, is full of surprises. Strange landscapes, alien life forms, environments that stretch the limits of biology. It raised a powerful question. If life can survive here, what else might exist out there? Could Europa's icy oceans hide something similar? Could Enceladus or Titan host alien ecosystems under their frozen crusts? NASA's Jet Propulsion Laboratory has used its experience building Mars rovers and space probes to help with ocean exploration. The same technology used to land on Mars can be adapted for the crushing depths of Earth's oceans. NASA's tools must be autonomous, durable, and precise, qualities essential for exploring both outer space and the deep sea. One of the most promising ocean projects was a collaboration between NASA and Woods Hole Oceanographic Institution. Together, they developed Orpheus, a next-generation underwater robot built to explore hadal zones. But the journey has not been without loss. Earlier, a vehicle named Nereus was lost to a catastrophic implosion. That implosion happened nearly 33,000 feet underwater, in the Kermadec Trench. It was a sobering reminder of just how unforgiving the ocean can be. Yet the work continues. In 2024, a NASA-supported probe drilled into volcanic crust at the bottom of the ocean, revealing something no one expected. Inside the Earth's veins, where molten rock meets freezing seawater, scientists found ecosystems teeming with life. Here, in temperatures over 700 degrees Fahrenheit and pressure strong enough to flatten steel, tiny organisms not only survived, they flourished. These extremophiles are the strongest evidence yet that life can thrive anywhere, even beyond Earth. These bizarre creatures are like nothing on the surface. Some glow in the dark. Others survive without a single ray of sunlight. There are bacteria that live entirely off chemicals, worms taller than a human arm, and fish that would look more at home on an alien planet. It's in these forgotten corners of our world that NASA sees the greatest possibilities. The deep sea is not just Earth's last frontier, it's a mirror of other worlds. And as NASA continues to dive deeper, what they learn in the crushing darkness below might help us one day find light among the stars. These incredible deep-sea organisms have developed fascinating ways to survive in the most extreme and isolated parts of our planet. In places where sunlight can never reach, they've mastered entirely new strategies to feed, reproduce, and even flourish. One of the most remarkable examples is the ecosystem around hydrothermal vents. These are underwater geysers that erupt with mineral-rich, superheated water. Despite the scalding temperatures and lack of light, life thrives here. The entire ecosystem doesn't rely on sunlight at all but instead depends on a process called chemosynthesis, where bacteria convert chemical energy into food. It's a completely alien system of survival. What's even more mind-blowing is that despite all of our technological advancements, we've only managed to explore around 5% of the Earth's oceans. That means an astonishing 95% of our ocean remains unexplored, untouched, and cloaked in complete mystery. We have no real idea what might be hiding in the crushing darkness miles beneath the surface. What bizarre, undiscovered species are swimming silently in those abyssal waters? Every new expedition has the potential to reveal creatures that seem more like science fiction than reality, and in some cases they've already done just that. Take the gulper eel for instance. It looks like something straight out of an alien horror movie. This bizarre creature has a mouth so large that it dwarfs the rest of its body. The gulper eel's jaw is hinged, which allows it to swing open its mouth and engulf prey much larger than you'd expect. While it might seem terrifying, it mainly feeds on fish, crustaceans, and cephalopods. Measuring around 2 to 3 feet long, the gulper eel has another defense trick. It can puff itself up into a balloon-like shape when threatened, making it appear larger and more intimidating. When it's time to eat, the gulper eel scoops prey directly into its oversized mouth. It then squeezes the water out through its gills and teeth before swallowing the unfortunate catch whole. The prey is trapped by the eel's stretchy skin, slowly funneled down the throat, and dropped alive into its massive, balloon-like stomach. It's a creepy and efficient predator. But believe it or not, this isn't even the strangest thing lurking in the deep. Meet the so-called headless chicken monster, a nickname that perfectly captures the weirdness of this next creature. Despite looking like something from another planet, the headless chicken monster is actually a deep-sea swimming sea cucumber. As it drifts through the dark waters, it moves with a creepy, webbed fin and has a mouth that resembles the Sarlacc pit from Star Wars. The deep red color that you see on its body isn't skin, it's actually completely transparent, and what you're viewing are its organs and skeleton from the inside. It's typically found at terrifying depths, ranging from 9,800 to 13,000 feet beneath the surface. It feeds by using its tentacles to grab and filter dead organic particles that settle on the ocean floor. Even with its spooky appearance, the headless chicken monster might not be the most unsettling creature found in the ocean's depths. That title could easily go to the frilled shark, an ancient predator that has barely changed over the past 80 million years. Yes, that means this terrifying creature was swimming around while dinosaurs roamed the land. It can grow up to 7 feet long and is named after the frilly, ruffled look of its gills. It's technically a shark, but it swims more like an eel with slow, slithering movements that only add to its eerie vibe. What makes the frilled shark even creepier is its unique jaw structure. Inside its long mouth are around 300 backward-facing, needle-sharp teeth arranged in dozens of rows. Once the prey enters its mouth, those terrifying teeth make sure it never escapes. It usually feeds on squid, swallowing them whole. Even though it's not one of the ocean's most aggressive predators, it definitely looks like something you'd never want to encounter. But for pure destructive power, one deep-sea creature takes the crown, and it's surprisingly small. Meet the mantis shrimp, a brilliant, rainbow-colored assassin that packs one of the most powerful punches in the animal kingdom. Despite being just 6 inches long, the mantis shrimp is built like a weapon. It has specialized limbs that act like clubs, delivering a knockout punch equivalent in speed to a .22 caliber bullet. That's fast enough to break through aquarium glass and crack open hard-shelled prey like crabs and mollusks. In fact, the pressure of the strike creates a bubble that momentarily reaches temperatures of 7,000 degrees Celsius, the same heat as the surface of the sun. This cavitation effect results in a flash of light and sound as the bubble collapses, disorienting or even killing prey before the actual punch lands. The mantis shrimp is also famous for its extraordinary eyesight. While humans see only 3 basic colors, red, green, and blue, mantis shrimp can detect up to 12 different color wavelengths. Their vision is so advanced it's like they're seeing a completely different world. And they're not alone in having deep evolutionary roots. Another ancient creature still swimming in the dark today is the vampire squid, known by its ominous scientific name, Vampirotuthis infernalis, which literally translates to vampire squid from hell. But this name is misleading. It's neither a true squid, nor is it a vampire. The vampire squid captures marine snow, organic debris like dead plankton and other decaying matter that slowly sinks from upper ocean layers. It uses long, sticky filaments to trap and collect this food. With its soft, jelly-like body and cloak-like webbing that connects its arms, the vampire squid can transform its shape when threatened, flipping its cloak inside out to appear larger and covered in spines. Despite its fearsome appearance, it's harmless and doesn't even hunt live prey. Fossil records suggest it's been around for at least 300 million years, long before dinosaurs and even before the formation of many modern continents. Sharing the deep sea with the vampire squid is another massive relic of prehistory, the Japanese spider crab. These massive creatures belong to a group of true crabs that originated in the Jurassic period, around 200 million years ago. Known for their colossal leg span, Japanese spider crabs can reach up to 12.5 feet from claw to claw, though their central body is just 15 inches wide. They live in the deep waters of the Pacific Ocean near Japan and are scavengers, feeding on algae, dead animals, and mollusks. Despite their monstrous look, They are considered gentle giants and are rarely seen in aquariums due to their size. Even older than the spider crab is the horseshoe crab, a true survivor of Earth's most catastrophic events. These armored creatures have been around for over 445 million years and have managed to outlive multiple mass extinction events, including the one that wiped out the dinosaurs. What's the secret to their survival? Flexibility in diet and a remarkable immune system. Horseshoe crabs eat practically anything and have copper-based blue blood that clots around bacteria, effectively neutralizing infections. Despite their name, they're not true crabs but are actually more closely related to spiders and scorpions. And while they may look intimidating, they pose no threat to humans. But even the mighty horseshoe crab is outdone in terms of age by one truly ancient mariner, the chambered nautilus. This elegant, spiral-shelled cephalopod has a fossil record stretching back 500 million years. That's 300 million years before the first dinosaurs appeared. Today, only 6 known species of chambered nautilus remain, and their form has barely changed over the eons. The nautilus uses its unique, chambered shell to control buoyancy, adding new chambers as it grows and occupying the outermost one. It has up to 90 tentacles and uses a beak-like mouth to feed on fish and decaying material on the ocean floor. Up to 20 years, that's the potential lifespan of a cephalopod like the chambered nautilus. That might not seem long compared to many land animals, but in the underwater world, especially for cephalopods, it's surprisingly enduring. Most octopuses live just a few years, some even less than a single year. The nautilus stands out with its spiraled, elegant shell that has captivated marine biologists and divers alike for generations. Its design isn't just beautiful, it's functional too, helping it maintain buoyancy in the deep ocean. But as we descend further into the ocean's dark depths, we're about to meet some creatures that make the nautilus seem almost ordinary. Let's dive into an even stranger world and meet a creature that looks like it stepped straight out of a science fiction film. The Yeti crab. Just one glance at this fascinating animal and you'll understand where it gets its name. Covered in what appears to be silky blonde hair-like strands, the Yeti crab is unlike anything you've seen before. These fibers, known as setae, resemble the fur of the mythical Yeti or abominable snowman, lending the creature its unusual and memorable name. But these hairs aren't just for show, they serve an extraordinary purpose that makes this crab one of the most uniquely adapted creatures in the ocean. Yeti crabs don't live in cozy coral reefs or calm sandy seafloors. Instead, they thrive in some of the harshest environments on Earth, deep-sea hydrothermal vents. These are extreme regions where superheated, mineral-rich water pours out of the Earth's crust, sometimes reaching temperatures of over 700 degrees Fahrenheit. Almost no sunlight penetrates these depths and the pressure is immense. Yet, the Yeti crab has found a way to not just survive, but thrive. Those so-called hairs on their claws actually host colonies of bacteria. These bacteria perform a process called chemosynthesis, converting the vent's toxic chemicals into usable organic material. In a sense, the Yeti crab farms these bacteria by waving its claws in the mineral-rich waters, feeding the bacteria, and then feeding on them. This mutualistic relationship is a brilliant example of deep-sea innovation. The crab provides the bacteria with nutrients and exposure to vent chemicals. In return, the crab gets a steady food source. In a place where almost nothing edible exists, this relationship can mean the difference between life and death. But while the Yeti crab is certainly fascinating, it's not the only strange crustacean lurking in the deep. Another odd character from the ocean floor is the box crab, an animal that combines mystery, strategy, and a bizarre mating ritual that seems more like something out of a science fiction romance novel. The box crab is a master of disguise and stealth. With its rounded, compact shape and unique behavior, it knows how to blend into the seafloor, making itself virtually invisible to predators and prey alike. But what really sets this crab apart is its peculiar reproductive behavior. During mating, the male box crab grabs a female and carries her around, sometimes for days. He doesn't just guard her. In some cases, he even buries her to keep her hidden from potential threats. Strangely, the female doesn't resist. She remains with the male until she molts her outer shell, at which point mating is completed. This odd ritual has baffled scientists and remains one of the more mysterious behaviors in the animal kingdom. And while not much more is known about this elusive crab, we do know one more thing. It's considered a delicacy in some parts of the world. Being closely related to the king crab, it shares a similar taste and texture, though catching one is no easy task due to the great depths at which it resides. These hidden corners of the sea aren't just filled with strange crabs and crustaceans. There are also eerie and alien-looking fish that roam these waters, rarely seen by human eyes. One of the most terrifying among them is the goblin shark, a creature that seems more like a prehistoric monster than a modern-day predator. The goblin shark lives up to its name. With its flattened, elongated snout and protruding jaws that shoot forward to snatch prey, it looks absolutely otherworldly. Its mouth is filled with razor-sharp teeth, and it can launch its jaw outward with lightning speed, a rare adaptation seen in very few sharks. This feeding technique helps the goblin shark catch fast-moving prey in the pitch-black waters of the deep. Scientists refer to it as a living fossil because it belongs to a lineage that dates back over 125 million years. It has changed very little over that vast stretch of time, giving researchers a rare glimpse into the ancient past of shark evolution. Goblin sharks are found at depths between 1,000 and 4,000 feet below the surface, making them extremely elusive. Because they inhabit these unreachable zones, encounters with them are incredibly rare, and much of what we know about them comes from occasional bycatch and deep-sea fishing operations. But the goblin shark is just one of many strange inhabitants of the abyss. Deeper still swims one of the most mysterious and rarely seen creatures in the ocean, the giant oarfish. This magnificent and eerie animal is considered the longest bony fish in the world, with some individuals measuring up to 56 feet in length. That's nearly the length of a semi-truck. Despite its size, the giant oarfish is a gentle giant. It typically lives at depths ranging from 650 to over 3,000 feet, surfacing only when sick, dying, or disoriented. Its ribbon-like body undulates through the water in slow, graceful movements, often resembling a serpent or mythical sea dragon. In fact, sightings of oarfish throughout history are believed to have inspired legends of sea serpents among sailors. But perhaps the strangest thing about oarfish isn't its appearance, it's the folklore surrounding it. In Japan, the oarfish is considered an omen of natural disaster. Local legends say these fish surface in large numbers before earthquakes or tsunamis, earning them the nickname messengers from the sea god's palace. While science hasn't confirmed any real link between oarfish sightings and seismic activity, the myth persists. And as recently as a few years ago, an oarfish was spotted near the surface by divers, an extremely rare event that quickly sparked local chatter about whether an earthquake might follow. While the ocean holds no shortage of legends, it also holds mysteries grounded in science, like the deep-water stingray, a unique species that differs from its shallow-water cousins in fascinating ways. These stingrays live in depths between 660 and 6,600 feet and are often referred to as six-gill stingrays, thanks to the 6 pairs of gill slits on their undersides. Most other rays and sharks have only 5. This subtle difference hints at a much older evolutionary lineage. The body of the deep-water stingray is more wedge-shaped than flat, which helps it glide through the thick water pressure of the deep sea. Its tail is incredibly long, often multiple times the length of its body, and like other stingrays, it may possess a venomous barb used for defense. These animals are carnivorous, using powerful jaws to crush small fish and invertebrates. Surprisingly, these rays give birth to live young, a trait they share with many other elasmobranchs. Fossil records suggest deep-water stingrays have existed for more than 400 million years, surviving multiple mass extinction events and adapting to some of the most challenging conditions on the planet. Now let's take a look at an eerie, spindly creature that looks like it belongs on another planet, the sea spider. Despite the name, sea spiders aren't true spiders and don't belong to the arachnid family. Instead, they're part of a separate class known as Pycnogonida. These creatures have tiny bodies and long, spindly legs, sometimes reaching a span of nearly 28 inches. Despite their unsettling appearance, most sea spiders are harmless, and many are no larger than a human thumb. What makes them fascinating is how their internal organs, including parts of their digestive and circulatory systems, extend into their legs. That's right, their bodies are so small that their organs have to stretch into their limbs to function properly. Sea spiders don't have an abdomen like true spiders. Instead, their cylindrical body houses just the essentials, making them look like walking skeletons. They use a long, straw-like proboscis to suck nutrients from soft-bodied animals like sea anemones, sponges, and jellyfish. Fossil evidence suggests these creatures have existed for over 430 million years, meaning they've outlived the dinosaurs and survived several global extinction events. And just when you thought these deep-sea creatures couldn't get stranger, meet the bigfin squid, a creature so rare and so alien-looking that scientists had only confirmed a dozen sightings until recently. In 2020, researchers made headlines by recording bigfin squids in Australian waters for the first time, adding to the growing list of known locations. Bigfin squids inhabit the darkest parts of the ocean, living at depths of 3,000 to 15,000 feet. Their bodies aren't particularly large, just 6 to 7 inches long, but their arms and tentacles can be up to 20 times that size, giving them an overall length of up to 26 feet. These limbs hang down at sharp angles and are covered in microscopic suckers, adding to their bizarre, ghostly appearance. Very little is known about their diet, reproduction, or behavior, but each new sighting brings us closer to understanding one of the ocean's greatest mysteries. As we slowly resurface from our journey into this alien world beneath the waves, we're reminded that there is still so much about our own planet that remains unknown. From bacteria-farming crabs and shark relics to ribbon-like fish and spindly-legged sea spiders, the deep sea is filled with marvels we're only beginning to understand. But these discoveries aren't just about Earth's oceans. They also hold clues about what lies beyond. If life can adapt and survive in the crushing darkness of hydrothermal vents or the freezing waters of the deep sea, who's to say life can't exist on other planets and moons under similar conditions? That brings us to Europa, one of Jupiter's icy moons and one of the most promising places in our solar system to search for extraterrestrial life. It may be cold, desolate, and battered by radiation, but beneath its thick icy crust may lie something remarkable. Europa is roughly 90% the size of Earth's moon, with a surface composed entirely of solid ice. Temperatures can plunge to minus 150 degrees Celsius, and yet, all signs point to a vast ocean hidden beneath its frozen exterior. In 1997, NASA's Galileo spacecraft passed just 125 miles above Europa's surface and recorded something extraordinary, what appeared to be a plume of water vapor erupting from the ice. At the same time, Galileo's magnetometer detected strange readings, anomalies that scientists believe could indicate the presence of liquid water interacting with Jupiter's magnetic field. When exposed to sunlight, ionized water molecules can produce such magnetic signals, supporting the idea of an underground ocean. The spacecraft didn't merely fly near one of Europa's geysers. It actually passed directly through a water vapor plume erupting from beneath the moon's icy surface. This incredible moment gave scientists the most direct evidence of subsurface activity on Europa. Later, in 2013, the Hubble Space Telescope provided further confirmation. It captured a series of images where visible traces on Europa's lower left section suggested the presence of massive geysers erupting from the ice. These geysers, according to estimates, can reach heights of several hundred kilometers before collapsing back onto the moon's surface like icy rain. Scientists were astonished to calculate that every 8 minutes, enough water is ejected from beneath Europa's ice to fill an Olympic-sized swimming pool. This statistic paints a vivid picture of how dynamic Europa's subsurface ocean must be. The water constantly interacts with the outer environment through these eruptions. With such activity and scale, there's no doubt now that Europa harbors a massive body of liquid water beneath its surface. In fact, estimates suggest the ocean may be as deep as 60 miles, and the total volume could be over twice the volume of all of Earth's oceans combined. These dramatic geysers are only part of the evidence supporting the existence of a liquid ocean beneath Europa's icy shell. Another significant clue comes from Europa's rotation. Recent studies reveal that the moon's crust rotates at a different speed than its internal core. Sometimes it moves faster, sometimes slower, but it clearly decouples from the deeper parts of the moon. This variation is due to Jupiter's powerful gravitational pull, which causes tidal forces that deform the moon, sliding its icy shell unevenly over the underlying ocean, proving the presence of a liquid layer. This movement, or chaotic ice drift, wouldn't be possible without a vast ocean separating the icy crust from the moon's solid core. Jupiter's gravitational influence essentially kneads the moon like dough, creating internal friction and heating that helps keep the water beneath the ice in a liquid state. The side of Europa that faces Jupiter experiences more gravitational pull than the far side, causing stretching, squeezing, and the formation of long surface fractures. These features were first observed in detail by the Galileo spacecraft, confirming that powerful tidal forces are constantly shaping Europa's surface and interior. Galileo also made another intriguing observation. While passing by Europa, it detected a disruption in Jupiter's magnetic field in the space around the moon. This anomaly indicated that something conductive, likely a global salty ocean, was interfering with the magnetic lines. Based on Europa's icy and potentially salty composition, scientists believe this interaction is most likely caused by a subsurface ocean rich in dissolved salts. This ocean, hidden beneath an estimated 10 to 15 miles of thick ice, would be electrically conductive, supporting the idea of a vast, hidden sea beneath the surface. This ocean is likely completely shielded from external radiation due to the thickness of the ice, creating a stable, protected environment, an essential factor for life to potentially emerge and evolve. So, why do scientists take this so seriously? Why do they believe life could exist in such a cold, sunless environment? The answer lies in Earth's own history. We already know that liquid water is a fundamental requirement for life. On Europa, there's not only liquid water, but it's also in motion, interacting with the silicate mantle, meaning minerals and energy sources are circulating constantly. This interaction could provide essential nutrients and conditions similar to those found near hydrothermal vents in Earth's oceans. And while the sun doesn't reach Europa's ocean, it doesn't have to. The heat from tidal flexing, combined with possible volcanic activity beneath the icy crust, could generate the thermal energy necessary to sustain ecosystems. On Earth, entire communities of life thrive around volcanic vents deep beneath the ocean, organisms that have never seen sunlight. The same kind of life could exist on Europa, feeding on chemical energy rather than photosynthesis. Even more compelling is the evidence that Europa has the chemical building blocks of life. Recent Hubble observations detected carbon dioxide on Europa's surface, likely originating from the subsurface ocean. This wasn't brought by meteorites or contamination, it came from within. In infrared images taken by Hubble, a bright white patch of carbon dioxide clearly stood out against the Moon's icy blue terrain. What's more, the carbon dioxide appears to be geologically fresh, suggesting that whatever process released it from below is still active, possibly ongoing even now. This opens the possibility that some form of carbon-based life could be evolving beneath the ice right now. Additional chemical compounds have also been found, including hydrogen peroxide, which plays a key role in methanogenesis, the production of methane by certain microbes. This is another pathway for life to exist without sunlight. But one of the most striking findings came from the Juno spacecraft during a close flyby on September 29, 2022. Passing just 220 miles above Europa's surface, Juno detected atomic hydrogen ions, suggesting the presence of oxygen in the Moon's tenuous atmosphere. This oxygen is produced when radiation from Jupiter bombards Europa's surface, splitting water molecules into hydrogen and oxygen. While much of the oxygen escapes into space, researchers estimate that Europa still produces roughly 12 kilograms of oxygen every second. That's enough to support 1 million people for a day. Scientists believe some of this oxygen may sink through the ice via cracks or other geological processes, eventually reaching the subsurface ocean. If that's true, then Europa has not only water and energy but also oxygen, another key ingredient for supporting complex life. Of course, for life to develop beyond a few simple microbes, time is essential. Life doesn't emerge overnight, it takes billions of years of chemical reactions, environmental stability, and evolution. That's another reason Europa is so compelling. Estimates suggest its subsurface ocean could have existed for over 4 billion years, just as long as Earth has hosted life. Throughout that time, the ocean beneath Europa has remained isolated and stable, shielded from harmful radiation and cosmic impacts, potentially giving rise to alien life, primitive or even complex, evolving completely separate from Earth's ecosystem. But what would life look like on Europa? Most scientists are cautious in their expectations. The most likely life forms would be microscopic, resembling the bacteria and archaea that thrive near hydrothermal vents in Earth's oceans. These chemotrophic organisms use chemical energy instead of sunlight to survive. Some researchers go a step further, hypothesizing the presence of multicellular organisms as well. In theory, Europa's ocean floor could host a food chain, beginning with simple microbes feeding off chemical reactions, then more complex organisms feeding on those microbes, similar to herbivores and predators in Earth's ecosystems. These hypothetical predators might resemble deep-sea creatures from our own planet, adapted to total darkness, crushing pressure, and extremely cold temperatures. While it may sound like science fiction, it's not without precedent. In fact, scientists often point to one of the greatest earthbound analogues for this idea, Lake Vostok in Antarctica. This subglacial lake lies beneath 2.5 miles of ice and has been sealed off for millions of years. When researchers finally sampled its water, they discovered unique forms of bacteria that had never interacted with the outside world, proving life can survive in total isolation. The discovery of life in such a place gave scientists a crucial reference point. If life can exist in Lake Vostok, then life could very well exist beneath Europa's icy crust. With all this evidence piling up, NASA has moved forward with one of its most ambitious missions ever, the Europa Multiple Flyby mission, also known as Europa Clipper. This mission is a milestone in planetary exploration. The star of this operation is the Europa Clipper spacecraft, which is designed to conduct dozens of flybys around Europa, gathering data and scanning the moon from every angle imaginable. The mission officially launched on October 14 of this year, propelled into space aboard a SpaceX Falcon Heavy rocket. This rocket gave Europa Clipper enough velocity to travel all the way to Jupiter, where it will begin its mission around Europa. At 12,000 pounds, Europa Clipper is the largest spacecraft NASA has ever sent to explore a planetary body. When fully deployed, its antennas and solar panels span an enormous 100 feet from end to end, larger than a full basketball court. Its wingspan is around 58 feet wide, making it a technological marvel. The solar panels, developed at NASA's Kennedy Space Center, are the largest ever built for a deep space planetary mission. Each panel is about 46 feet long and 13 feet high, specially designed to absorb as much sunlight as possible at Jupiter's great distance from the Sun, which is about 5 times farther than Earth. These panels are vital as they'll power all of Europa Clipper's systems during the mission. But they're only one part of what makes this spacecraft so impressive. Europa Clipper is equipped with 9 advanced scientific instruments to explore Europa like never before. Among these instruments is a powerful radar system capable of penetrating Europa's thick ice shell. It will bounce radio signals deep into the ice and then analyze the echoes to create a 3D map of the interior structure. This will help scientists identify potential pockets of liquid water, determine ice thickness, and detect any subsurface lakes. High-resolution cameras will also provide the clearest images of Europa's surface to date. The most advanced camera on board can detect features as small as 20 inches, 12 times better resolution than what we got from the Galileo mission decades ago. The images that were once taken by the Galileo spacecraft helped inspire the mission design of Europa Clipper, but this time, NASA is using much more advanced technology. One of the most exciting tools on board will be an infrared thermal imaging system. This device will attempt to detect warmer regions on Europa's surface, places where liquid water might lie just beneath the icy crust or where water may have been recently expelled. While the radar and cameras are observing from a distance, other specialized instruments will take a more direct approach, collecting gas and dust particles from the surrounding environment to analyze their chemical composition. These samples may provide key insights into what's happening beneath Europa's frozen shell. But science isn't the only thing aboard Europa Clipper. Like many missions before it, the spacecraft also carries a symbolic message from Earth. This time, that message includes a poem written by U.S. poet laureate Ada Limon. Her words have been etched into memory alongside the names of millions of people from nearly every country in the world. These names were inscribed onto a microchip, which is sealed beneath a tantalum plate that protects the spacecraft's electronic memory. As an artistic touch, the plate also features wave-like patterns representing water, with the word water engraved in over 100 different languages, an especially meaningful tribute considering the mission's quest for liquid water and the possibility of life on Europa. Getting to Europa, however, is not a simple journey. The spacecraft must travel nearly 1.88 billion miles before it can even begin its science mission. Propelling a spacecraft that far using just its engines would require an impossible amount of fuel, so engineers have devised a smarter way. Europa Clipper will use gravity assists from Earth and Mars to gain speed. These planetary slingshots allow the spacecraft to build momentum without using additional fuel. In 2025, it will pass close to Mars, then loop back toward Earth in 2026 for another gravity assist. From there, it will be flung out toward Jupiter at even higher velocity. The spacecraft is expected to reach Jupiter in 2030. As it nears the massive gas giant, it will need to slow down drastically in order to be captured by Jupiter's gravity. To do this, Europa Clipper will fire its engines for 6 to 8 hours in a controlled maneuver that will insert it into orbit around Jupiter. Once captured, it will begin a series of 49 close flybys of Europa, sometimes passing as near as just 15.5 miles from the Moon's icy surface. These flybys will allow for incredibly detailed data collection, even though the spacecraft won't land. However, long before Europa Clipper settles into orbit around Jupiter, it must survive a dangerous space environment. Jupiter is the most radiation-intense planet in our solar system, second only to the Sun. As Europa orbits within Jupiter's powerful magnetic field, it travels through intense radiation belts that can severely damage spacecraft electronics. To protect its sensitive systems, Europa Clipper's electronics are shielded inside a specially designed vault made from thick aluminum and zinc. While this should provide strong protection, the environment is so extreme that some level of risk still remains. It's one of the biggest engineering challenges of the mission. Once safely in orbit, Europa Clipper's 4-year mission will begin. The spacecraft will carry out 49 planned close flybys of Europa. With each pass, it will collect high-resolution images and scientific measurements. One of the key objectives is to determine the thickness of Europa's ice shell and understand how it interacts with the vast subsurface ocean beneath. The mission will also investigate the chemical makeup of the surface and any plumes of water vapor that might erupt into space. Using powerful cameras, Europa Clipper will search for the best location to eventually send a lander, ideally a place where the ice is thinner and the ocean is more accessible. At first glance, it might seem impossible to find evidence of life without landing or drilling beneath the surface. But Europa Clipper may still find important clues. One major hope lies in the detection of geysers, massive plumes of water vapor that might be expelled from the moon's interior through cracks in the ice. Similar to the plumes observed by Galileo years ago, these geysers could eject material from deep within Europa's ocean all the way into space. If life exists in that ocean, whether as simple bacteria or more complex organisms, it's possible that traces of it could be frozen in the ice particles ejected into space. If Europa Clipper passes through one of these plumes at just the right moment, it could directly sample the particles using onboard instruments. Even a tiny piece of organic material could provide groundbreaking evidence that life exists, or once existed, on this distant moon. Admittedly, the chances of such a flyby aligning perfectly with a geyser eruption are slim, but they are not zero. Scientists remain hopeful that even without a lander, Europa Clipper will bring us closer than ever to answering the question of whether life exists beyond Earth. Once the mission is complete in 2034, Europa Clipper won't return to Earth. Instead, it will be intentionally crashed into Ganymede, Jupiter's largest moon and the biggest satellite in our entire solar system. Interestingly, Ganymede is also believed to contain a subsurface ocean, but its outer ice shell is much thicker than Europa's, possibly extending 100 miles deep. This makes it a more difficult target for exploration. Still, the controlled impact of Europa Clipper could help scientists study Ganymede from afar without risking contamination of Europa or other moons that might harbor life. Ganymede isn't the only moon believed to have a hidden ocean. Callisto, another of Jupiter's large moons, may also conceal an ocean beneath an even thicker crust of ice. But even more famous than these is Saturn's moon Enceladus. Like Europa, Enceladus has shown signs of active geysers, which shoot water and ice particles into space, some of which have already been sampled by the Cassini spacecraft. Titan, Saturn's largest moon, is also a world of great interest. Though it's much farther from Earth, Titan has its own subsurface sea, and a landscape that, in many ways, resembles our own planet. Titan is massive, bigger even than Mercury, and yet it isn't just its size that's impressive. The moon's surface features lakes, rivers, and seas. But instead of water, these are made of liquid methane and ethane. Beneath the surface, however, lies an ocean of water, shielded by a crust of ice. Titan's thick atmosphere is made mostly of nitrogen and methane and is so dense that you wouldn't even need a pressure suit to walk on the surface, just oxygen and thermal insulation. Its gravity is only 14% of Earth's, so if you had wings on your suit, you could actually fly by flapping your arms. Because of this low gravity, rain on Titan falls much more slowly, about 6 times slower than on Earth, and the droplets are larger. But this isn't water, it's methane rain. Titan orbits Saturn from about 750 million miles away, completing one orbit every 16 Earth days. Although it's tidally locked to Saturn, meaning the same side always faces the planet, Titan still has dynamic weather. Its thick atmosphere is 10 times higher than Earth's and lets in very little sunlight, so the surface is usually shrouded in a dim orange haze. During the daytime it's like peering through dense smoke, and the light is often 100 to 1,000 times dimmer than on Earth. Surprisingly, Titan's brightest moments come not during the day but at twilight. Computer simulations suggest that the scattered light from the atmosphere can make twilight up to 200 times brighter than midday. And because the moon is tidally locked, Titan has a permanent twilight zone at the boundary between its day and night sides. Titan also experiences solar eclipses, which can last up to 6 hours. These only occur if you're on the side facing Saturn. Otherwise, they happen during Titan's long night. Understanding these light patterns is crucial because they affect how energy is distributed across the moon's surface, which in turn influences the chances for life. Dust storms, something we often see in the dry, arid regions of Earth, also happen on Titan, but in a much more alien form. Just like on Earth, massive dust clouds can form before storms arrive. The only other place in our solar system where similar dust storm behavior has been observed is Mars. On Titan, however, these dust clouds aren't just regular dirt. They're made up of complex organic particles. These organic dust grains settle across Titan's surface, shaping its terrain over time. Even though rainfall is rare here, when it does happen, it leaves behind very noticeable and fascinating changes. Titan's rare but powerful downpours can reshape its surface dramatically. These storms lead to the creation of features known as alluvial fans, landforms that look like triangular piles of sediment. They're formed when flowing liquids like methane or possibly icy slurries move across Titan's surface, carrying with them small rocks and dust. Once the flow slows down, it drops its load, leaving behind these fan-shaped deposits. On Earth, we often see these features at the end of rivers or after heavy rain in mountainous areas. Titan, despite being so far from us, mirrors this natural process in its own strange way. Another surprising feature on Titan is its vast dune fields, which make up about 13% of the Moon's surface. These aren't your typical sand dunes either. They're colossal, stretching for hundreds of miles, up to 1.2 miles wide, and towering 330 feet high. In fact, Titan has more sand than any place we know in the entire solar system. But this sand isn't made of silicate like it is here on Earth. Instead, it's composed of solid hydrocarbons, complex organic compounds that fall from Titan's thick atmosphere like rain, accumulating on the ground and reshaping the alien landscape. On Earth, sand dunes are formed through a familiar and straightforward process. Rocks break down into grains, and wind carries them to different areas where they eventually pile up, creating dunes. But Titan defies that simplicity. Scientists have long struggled to understand how Titan's sand dunes remain so large and stable. The sand grains here are made of weaker organic compounds, which should break apart and erode over time. But oddly enough, these grains persist, forming stable, long-lasting structures. This poses a strange question. What's keeping these fragile grains from disappearing into Titan's turbulent atmosphere? After closely studying Titan's landscape, scientists uncovered something truly remarkable. They found that Titan has a unique sedimentary process. Instead of grains simply colliding and breaking down like they do on Earth, on Titan, these grains can actually fuse together when they smash into one another. This fusion forms larger, stronger pieces of sediment, which are far more durable and less likely to be swept away by Titan's fierce winds. It's a form of natural reinforcement. And if even sand can adapt to such alien conditions, one can't help but wonder, could life on Titan have adapted in a similar, unexpected way? Despite how different Titan is from Earth, the similarities are still striking. Both worlds have lakes, rivers, rainfall, and atmospheric systems. But while Earth's systems run on water, Titan's environment uses liquid methane and ethane instead. Its clouds, rivers, and even lakes are made of these cryogenic chemicals. The ingredients are completely different, yet the behavior of these fluids mimics water in many ways. Titan remains geologically and atmospherically active, which suggests that it's far from a dead world. It's alive with strange processes that we're only beginning to understand, each one offering new insight into possible alien biology. The lakes on Titan aren't just quiet pools of methane. They undergo complex physical processes just like lakes do on Earth. One of those processes is stratification, where the liquid separates into layers based on differences in density. And these layers don't just sit still. Sometimes they erupt. Yes, Titan's lakes can actually bubble and erupt due to a chemical cocktail of methane, ethane, and nitrogen. These eruptions form powerful bubbles that can shift sediment and even shape river deltas. It's a dynamic process, indicating that Titan's surface is far more active and volatile than we once believed. Now, imagine the future, a submarine exploring Titan's icy lakes. Sounds incredible, right? But there's a catch. If this sub gives off heat, it could trigger those same methane bubbles, potentially causing an eruption around the craft. Scientists are carefully studying how bubbles form in Titan's lakes so they can prepare for these challenges. A spacecraft designed to explore this world would need to withstand not just the cold, but the unexpected behavior of alien liquids. It's one of many examples where Titan refuses to play by Earth's rules, forcing us to think differently about how we explore alien environments. Whatever form life might take on Titan, it would be unlike anything we've ever seen. According to researchers at Cornell University, it's theoretically possible for cell membranes, essential building blocks of life, to form in Titan's current conditions. On Earth, our cell membranes are made of molecules called phospholipids, which have both a head that loves water and a tail that avoids it. These molecules arrange themselves in water to create flexible, protective layers. But methane doesn't behave like water. It doesn't allow for the same structure. So if life exists on Titan, its membranes would need to be built completely differently. Methane has a very even electrical charge, which means the phospholipid membranes we see on Earth can't form there. But scientists have found a clever workaround. In labs, researchers have created special inside-out membranes that function in nonpolar liquids like methane. These structures are stable, resistant, and surprisingly similar in behavior to Earth-like membranes, even though they're made from different molecules. This opens up a fascinating possibility, that life, if it exists on Titan, could be built from entirely different chemistry. It would still follow some of the same basic biological rules, but with ingredients we've never seen in living organisms before. So what kind of molecule could replace phospholipids on Titan? Computer models have offered an answer: acrylonitrile. This substance can potentially form stable membranes in liquid methane. Interestingly, the Cassini mission detected small traces of acrylonitrile in Titan's atmosphere, about 10 parts per million. Despite the vast temperature differences between Earth and Titan, acrylonitrile-based membranes might share similar physical properties with phospholipid ones. They'd be stable, flexible, and capable of forming a protective barrier around a cell. That means Titan could theoretically support a kind of life totally alien to us, one that's optimized for methane-based chemistry in freezing conditions. If membranes like these can survive in Titan's methane lakes, the implications are huge. It would mean that life could exist in environments far outside the traditional habitable zone. Until now, scientists have mostly looked for life in warm, Earth-like conditions, planets with water, oxygen, and sunlight. But Titan suggests another path, a cold world where methane flows and life is built on hydrocarbons. Within our own galaxy, that would massively increase the number of worlds we might consider habitable. And with more candidates, the odds of discovering alien life, of any kind, grow larger than ever before. And if life on one of these frozen worlds has had time to evolve, it might not just be microbial. Could be complex. Imagine a creature built for Titan's extreme cold, with biology adapted to methane instead of water. These wouldn't just be weird bacteria, they could be full-blown organisms that function and grow in ways totally foreign to us. They might not even resemble life as we know it. But they could still think, move, and adapt. The kind of beings we've only ever imagined in science fiction might be lurking beneath Titan's clouds, waiting to be discovered. Even if Titan's surface isn't currently habitable, there's another possibility: a hidden ocean. Beneath the thick, icy shell of Saturn's largest moon, scientists believe there's a vast ocean of liquid water. If organic compounds from the surface can somehow travel down through the ice and into this subsurface ocean, then this hidden sea could become a potential cradle for life. We don't yet know its temperature, chemical composition, or whether it contains energy sources that could support metabolism, but it's one of the most promising places in the solar system to search for life beyond Earth. Earth wasn't always a warm, blue planet. Billions of years ago, it had an atmosphere rich in nitrogen, carbon dioxide, and water vapor. These early conditions kick-started the formation of life as we know it. Titan, in some ways, mirrors this ancient Earth. It's like a living laboratory for astrobiologists, a place where the building blocks of life may be undergoing their own strange experiments. Studying Titan might help us understand not just where life could exist in the cosmos, but how life originally began on our own planet, using similar ingredients under vastly different conditions. So what happens next? In June 2027, NASA plans to launch Dragonfly, a robotic helicopter designed specifically to explore Titan's surface. This advanced spacecraft will search for signs of organic molecules, study the composition of its terrain, and possibly probe for clues about its hidden ocean. It's not just about finding water anymore, it's about uncovering the potential for life in forms we've never imagined. With Dragonfly's arrival, we might finally get answers to questions that have puzzled scientists for decades. Could Titan host alien life? And if so, what would those otherworldly creatures actually look like? If life truly exists on Titan, it could change our understanding of biology forever. What if these beings don't breathe oxygen, or drink water, or use sunlight the way we do? What if they're thriving in the cold, building their cells from acrylonitrile instead of phospholipids, and swimming in methane lakes beneath an orange sky? Would we even recognize them as life? Or would they look so strange that we'd think they were just another part of the landscape? Whatever the case, Titan holds secrets we've only just begun to unlock. So, what do you think? What might alien life on Titan look like?